In this video, we will be reviewing the coordinate plane and how to find the domain and range of functions. Let's begin by reviewing the coordinate plane. The coordinate plane is made up of two axes. The horizontal axis is known as the x-axis. So I'm going to label that on the diagram. And notice that the x-axis goes forever to the right and forever to the left. So when it's going forever to the left, that's forever towards negative infinity. When it's going forever to the right, that's going towards positive infinity. The vertical axis is considered the y-axis. So I'm going to label that on the diagram. And notice that the y-axis goes forever downwards and forever upwards. So if it's going forever down, it's going forever towards negative infinity. And if it's going forever up, it's going forever towards positive infinity. The point where the two axes meet is known as the origin. The origin is always at the coordinate 0, 0. So I'm going to label that on my diagram. Those axes create four quadrants. The first quadrant is in the upper right-hand corner, and I'm going to use a Roman numeral 1. The second quadrant is in the upper left-hand corner. The third quadrant is in the lower left-hand corner. And then the fourth quadrant is in the lower right-hand corner. To locate a point on the coordinate plane, you need to know its ordered pair. When we're writing out an ordered pair, we always start with the x coordinate, which is how far to the left or the right you have to go to get to that point. And then it's always followed by the y coordinate, which is how far down or up you have to go to get to that point. So an ordered pair, therefore, looks like x, comma, y. So we're going to practice just plotting some ordered pairs on a graph. So the first point we're going to plot is at 2, 6, and we're going to label that as point A. So first we're going to look at the x-axis, and we're going to find positive 2. And then we're going to look at the y-axis, and we're going to find positive 6, and we're going to look for where do those two things meet. They meet at this point, which would be 2, 6. So I'm just going to put a point there, and I'm going to label that as point A. Now this may be review for you, but we're just going to kind of review it just so that you're comfortable with it, because you're going to need to be good at this in order to understand domain and range. Next, I'm going to label point B at -3, +7. So that would be here on the graph. Point C is at -5, -5. So I'm going to put a point on the graph at C. Point D is at 6, -3. Point E is at 8, 0. Point F is at 0, 5, which is on the y-axis. Point G is at -9, 0 on the x-axis. Point H is at 0, -7, which is on the y-axis. And then 0, 0 we already labeled as the origin, but I'm going to call that point I. So now that I have all my points labeled correctly, we're going to move on to the next page of notes, and we're going to talk about something called a function. So a function is a relation in which each element of the domain is paired with one element of the range. And in order to understand that definition, we need to define domain and range. So the domain is the set of all first values. And a lot of times we refer to the first values as the x values. The range is the set of all second values. And a lot of time we refer to second values as the y values. Something is considered not a function if an element of the domain is paired with more than one element of the range. Or that's just a fancy way of saying that no x's or no x values can repeat. If any of the x values repeat, then it would not be considered a function. So for these examples, we're going to state the domain, the range, and then determine whether or not it's a function. So the domain is just the set of all x values or first values. So it would be this first column, and we always write the domain and range in order from smallest to largest. So the domain in example 1 would start with -3, then +1, then +4. The range is the set of all second values or y values, which is going to be the second column. And if I put that in order from smallest to largest, it would be 2 and then 5. And then remember to determine if it's a function, no x value can repeat itself. So far, if I look at the arrows, they're all going to just one number. So none of them are repeating. So I would say, yes, this is a function since none of the x values repeat. In example 2, I'm going to put the x values or the first values in order from smallest to largest. So it would be -2, 0, +2. And then for the range, I'm going to put the y values in order from smallest to largest, which would be -4, 0, +4. Now, if you look carefully at example 2, the -2 is pointing at two different numbers. So therefore, the -2 is repeating. And since that's one of the x values repeating, this is not a function since the -2 repeats. Now, sometimes you're going to see examples that are not numerical. So for the domain and range, I just put them in alphabetical order. So if you look at the domain, Chicago would come first, then New York, then San Francisco, and then for the range, Cubs would come first, then Giants, and then the Mets. Now, if you look carefully, notice that New York is repeating because it has an arrow going to Mets and Giants. So since it repeats, this would not be a function. Okay, so again, just to kind of refresh your memory on what we've talked about, to determine if a correspondence is a function, the first thing we always do is we state the domain. The second thing we do is we state the range. And then the third thing we do is we determine if any x's repeat. So these examples are a little bit different than the ones we just did. So these are giving us ordered pairs. So again, just think of the domain as all the x values. So I'm only going to look at the x's, and you have to put them in order from smallest to largest. Now, if any of the x values or y values repeat, we only write them once in the domain or the range. We do not write them more than once. So it's kind of nice for this first example because the x values are already in order from smallest to largest. So it'd be -8, -3, 0, and then +1. You do not repeat the +1. You only write it one time. Then for the range, I'm going to look at the y values and put them in order from smallest to largest. Now, this is a little bit more challenging because the y values are out of order. So the smallest y value is -3, then +1, +7, and +10. Now, to see if it's a function, we're going to think about, do any of the x values repeat? And they do. In the first, or in the last point and second to last point, we both have a 1. So therefore, it's not a function because the x values are repeating. Let's try example 2 the same way. We're going to put the x values in order for the domain from smallest to largest. So I'm just going to look at the x values only. So -3 would be the smallest one, then 0, then +1, then +3. The range, we're going to put the y values in order next. So +2 would come first, then +4, then 5, then 7, then 8. And then again, the x values are repeating. The 1s repeat, so this would not be a function. In example 3, sometimes they'll give you the ordered pairs in a table, but you're still going to do the same thing. You're going to put, for the domain, the x values in order from smallest to largest. So we're going to write 0, and we're not going to repeat it. Then +1, +2, +3. For the range, we're going to put the y values in order from smallest to largest. So we would have -7, -3, +2, +4, and +8. To see if it's a function, we're going to look to see if any of the x's are repeating, and they are. The 0s repeat and the +2s repeat. So this again would not be a function. So hopefully after completing these notes, you have a better understanding of domain and range. Feel free to ask your teacher if you have any additional questions.